Let's do a little PFD, partial fraction decomposition. The first thing we need to do is factor the denominator. Whenever the denominator is factorable, we can use partial fraction decomposition. And if the denominator is not factorable, then you often will do a completing the square or something else if you have a quadratic in the denominator. So the first thing we are going to do is set up our form. So we're going to take the integrand, and we've got these two linear factors in the denominator. So we want to rewrite the integrand as a constant over each of those linear factors. So what we need to do is solve for a and b. We're going to multiply both sides by the denominator on the left. And when we multiply both sides by that denominator, we have some cancellation that will give us this. So just to be clear, we're taking this whole entire equation and multiplying it by x minus 5 times x plus 3, this double factor. And that double factor gets distributed across, and we get a cancellation of one of the factors in each of those terms. Okay, so here is where we have a choice. We can use the traditional method. This is our PFD equation. And we can use the traditional method, or we can use the convenient value method. When we have all linear factors, the convenient value method is way too convenient not to use. So we are going to let x be 3 throughout this whole equation. And if we plug in a 3 in this first place right there for x, we're going to get a 0, right? 3 minus 3 is 0. And then we plug in 3 in the second spot over here. 3 minus 5 is negative 2. So we get negative 2b. And now we can isolate b. b is going to be negative 3 divided by 2. Our second convenient value is x equals 5. On the left side of the equation, we have a 3. On the right side, 5 minus 3 is 2, so we have 2a. And then, similarly to what happened a minute ago, if we plug in the 5 there, we get 0. So it gives us a pretty fast way to get our unknowns here. So a will be 3 divided by 2. That allows us to rewrite our integral as follows. We're going to have a, which is 3/2 divided by x minus 5. And then minus 3/2 over x plus 3 dx. These are in log form. The integral of 1 over x minus 5 is the natural log of the absolute value of x minus 5. So we are going to end up with this constant, natural log absolute x minus 5, minus 3/2 absolute, natural log absolute x plus 3. This is a definite integral going from 0 to 2, so we'll have to calculate that. Let's see where we go. So plugging in the 2 first will give us 3/2 natural log of 3. 2 minus 5 is negative 3, but then we take the absolute value of it. And then minus 3/2 natural log of 5. And then we subtract off what we get when we plug in the lower limit of integration. So plugging in 0, we get minus 3/2 natural log of 5. And then minus a minus, so plus 3/2 natural log of 3. We have some terms that we can combine there, so let's go ahead and do that. So we have the ln of 3's right there, so we have 3/2 plus 3/2, which is 6/2, which is 3. So we have 3 ln 3, and then we have the natural log of 5's, so we have minus 3/2 minus 3/2, so that's minus 6/2, so that's minus 3 natural log of 5. There's a few things we could do here. We could factor out the 3 And then we have this, which you could rewrite as 3 natural log of 3/5. That's a possibility. It is totally fine to leave it in this form right there. That's a reasonable place to stop, but you can go the extra mile and get this more simplified answer if you wanted to. All right.